Hello again. Let's look at some more examples. Follow my cursor. Again, we're going to assume all variables are positive. The fourth root of 1,875x cubed, I know that looks like a really big coefficient there, minus the fourth root again of 48x cubed, so these are both fourth roots here and here, equals the fourth root of, now here's the trick. Since we're doing the fourth root, we would, for 1875, we would like to find, if it's even out there at all, the biggest well, if it's not equal to 1, which would be boring and not helpful. We'd like to find the biggest perfect fourth power that would go into 1875. And it's out there, namely 625, because 5 times 5 times 5 times 5, 4 times would give you 625. So, hey, there it is. So we break it up. So what we do for 18 and for x cubed, now x cubed's in trouble because 3 is smaller than 4. Well, if we tried to find the biggest multiple of 4 that's less than 3, that would be 0, but that's not helpful. So remember, another way of saying that, since 3 is smaller than 4, it can't come out. It won't even contribute anything that will come out of the radical. Or in this case, the radical is the fourth root, but anyway. Now for the 48x cubed, again, this x cubed is going to run into the same problem. Now 48 is, what's the biggest perfect fourth power that will go into 48? 16, because 16 is 2 to the fourth power, or 2 times 2 times 2 times 2. And so we break this up. Now notice, guys, when we first started this problem, it didn't look like these guys would subtract. They didn't look like like terms at all, but really they're like terms incognito. Because what's going to happen is, you see, this 625 comes out as a 5. That's for this first term. And for the second term, that 16 comes out as a 2. And now that wouldn't be all that exciting. And that by itself, wouldn't promise that we could do the next subtraction. But notice what's left over. The residues are the same. And since the residues are the same, we can do, and since the residues are both 3x cubes, and since what came out are just pure numbers, we can do the subtraction. So we got 5 times this guy minus 2 times this guy. That's just going to leave you 3 times this guy. So 5 times the fourth root of 3x cubed minus 2 times the same thing will give you 3 times the same thing. So there's that. And so we turned it into something we could do. Now, in general, just because you clean something up doesn't necessarily promise that this subtraction right here will carry forth. But I picked an example where it would indeed carry forth, okay? Let's look at this next example here. 7 times the fourth root of this guy. Now, let's just do the same two guys, but let's stick a multiplier of 7 in front here and a multiplier of 10 in front here. We go through the same steps. We filter out the 625 for this one and the 16 for this one. And again, that 625 comes out as a 5. And it's just going to multiply into that 7 and give you 35. And this 16 comes out as a 2 just like it did before, but it's going to multiply into that 10 on the other hand and give you 20. So you're going to have 35 times the fourth root minus 20 times the fourth root, and that'll give you 15 times the fourth root. And so that'll be all for that particular example. I just wanted to spice that last example up. Now let's say I've got radical 112x minus 3 radical 7x. Now, since I'm doing the square root, the index is understood to be 2, so I want to find the biggest square that will go into 112, and that would be 16. Namely 112 is 16 times 7, and so 112x is 16 times 7x. And then now, and then now the minus 3 times radical 7x, I can't clean that up. That's just there's nothing I can do with that particular term. So, but notice that 16 is a perfect square. It comes out, the square root of 16 is 4. So it comes out as a 4. So we get 4 radical 7x minus 3 radical 7x. And that's just 1 radical 7x. And that'll be all for that example. Now guys, I'm going to leave it for you to do this example and just for you to practice with. Let's look at this problem. Look, the square root of 4x minus the square root of 8x. Now the 4 comes out as a 2, Now, remember 8, the biggest perfect square that goes into 8 is 4, and that 4 comes out as this 2 right here. So I get 2 radical 2x minus, 2 radical x minus 2 radical 2x. That looks good, but we actually can't really do anything more with that because this is a radical x here, whereas this is a radical 2x here. So these are not like terms, and we can't really go any further. And I'll leave it for you to do this one. Let's stop the video and let me move on to the next video. I just wanted you to get some examples down on this video. Thanks, and we'll move on to the next video. Bye-bye.